Hello developers, welcome to day 2 of the 30 days of JavaScript challenge. Today marks another opportunity for us to tackle challenges and deepen our understanding of JavaScript concepts. Let's dive in and make the most of this learning journey. Today's challenge says, given an integer n, return a counter function. This counter function initially returns n, then returns one more than the previous value every subsequent time it is called. So you can look at the example there. For example, if the value of n is 10 and it is called 3 times, you can see that it is called 3 times. So it will return 10 first, then one more value than 10, then another value than the subsequent value of 11, that is 12. So when you call, if the value of n is 10 and you call it 3 times, it should return 10, 11, and 12. And here is the explanation. I've just said the explanation. So the first time the counter will return 10. The second time it's called, it will return 10 plus 1, that is 11. Then the third time it will return 11 plus 1, that is 12. The example 2 is the same way. If you call it 5 times, just the same thing. Here it was called 1, 2, 3, 4, 5 times, so it will return 5 values. And the first value is always the value of n. So that is our today's challenge. And the constraints are n can be any value between -1000 to 1000. And the calls can be either between 0 to 1000. So those are the constraints for this challenge. So let us learn some key concepts, then we solve the challenge. The first key concept that we learn is called the prefix notation. So in prefix notation, the operator appears before the variable. For example, if you're using prefix increment will be that, then the variable, or if it's decrement, it will be then the variable, like that. So let us start with the prefix increment. So if you're using the prefix increment operator, it increments the variable by 1, then returns the updated variable. So let's say you have an example, you have a variable x, it has the value of 5. Then let me just log the answer so that you can see. And to increment, and to use the prefix increment, I'll say like that. Then also let me log the value of x so that you can see the difference. So if I run this code, you can see it's 6, then the value of x will be 6. So you can see this one prefix, it first increments the value. So it was 5, it increments it to 6, then returns 6. Then now the new value of x will be 6. That's why when you log all of them, you'll see 6. The same thing happens when you use the decrement. It first decrements the value by 1, then returns the new value. So I can just also run this one so that you can see. You can see it will be 4, 4. So that is called prefix notation. And just to clarify, you have said that when you use the prefix increment operator, it increments the value, it increments the variable by 1, then returns the updated value. And if you use the prefix decrement operator, it decrements the value by 1, then returns the newly updated value. Let us look at the next one, that is postfix, and you see how prefix notation differs from postfix notation. First, in postfix notation, the operator appears after the variable. So if the variable is x, the operator will appear after the variable. That is the first thing that prefix differs from postfix. Then when you use the postfix increment, it increments the value of the variable by 1, then it returns the original value before the increment. Let us see it in action. So let's use the same variable x. Let's say I still have x here, that is 5. Let me just copy this code. Let me copy this. So I want to use the postfix. I've said postfix is after the variable. So if I use postfix increment, it will be like that. So I'll write the variable, then I'll increment it later. So let me run so that you can see the difference. So you can see here, this postfix returns 5, then 6, because line 10, it increments the value, but it does not return the new value. It returns the initial value before increment. But you have seen after you log x, you can see now x is 6, meaning it was incremented. But this line 10 here, it returns the initial value before it was incremented. The same thing happens when you use the postfix decrement, like that. So it will decrement, then it will return the same. Let me run so that you can see. You can see line 10 returned 5. It decremented the value to 4, but it did not return the new value. It returned the old value that was 5. Then if you log X, you can see indeed it was decremented. So that is how the postfix differs from the prefix. The postfix returns the old value before any operation is done, but the prefix returns the newly value. So that's the difference. I hope that was clear. Now that you know about the prefix notation and the postfix notation, we are able to solve our challenge. So let me just clear the code. So the challenge you're supposed to create, you are given an integer, you're supposed to return a counter function. So I'll use the closure method. So this first solution will be for closures. Then I'll provide another solution for object-oriented JavaScript. So let me start with the closures first. Since we know about closures, I believe we still remember about closures. So I'll create a function. Let me call it create counter. I'll use the anonymous function syntax. So I'll get that function like that. So this function will take an integer. So it will take n. Then it's supposed to return a counter function. So I'll return a function. I'll also use the anonymous syntax like that. So this function is supposed to return n, then one more value than the previous value. So I'll use the postfix notation because you have seen that the postfix, it returns the old value first, then increments and returns the new value like that. So I'll just use the postfix like that. I believe you understood about the postfix. Then we are able to access this n outside here, since it's not in this scope, but we can access it with the power of closures. So this is a closure. So I can just call this function. So I'll just call create counter. Let me just call it, this example, I'll call it the value 10. But keep in mind that this will return a function. It won't return the value, it will return a function. So let me just store it in a variable. Let me store it in a variable, say counter. Let me store it in a variable. Then now this variable is now a function. So I can call this function. Let me call it, here they call it 3 times. Let me call it 3 times also. So I'll say counter 3 times. That is 1, 2, 3, like that. So I expect this one to return 10. Then this second call, I expect it to return 11. Then the third call, I expect it to return 12. Because you have said that the postfix returns the initial value first, then returns the incremented value like that, and so on. So you can run this to check if it is correct. Let me just run it again. I'm not logging the answers. I'm supposed to log these answers. I'm wondering why it's not displaying, because I didn't log the answer. So let me log this console log. Okay, 3 times. 1, 2, 3. This one will be 11. This one should be 12. So you can see in the browser, it's the same 10, 11, and 12. And that is what our function expected. And also you can try this example too to see if it passes all. It was n should be -2. So if I call this one is -2, then I call it 5 times. That is 3, 4, 5. I expect the answers to be the answers that are written here. That is -2, -1, 0, 1, and 2. So you can run and confirm that those are the answers. So this code solves the challenge. This was using the closure method. Now let us use the object-oriented method. So yeah, that was with the closures. So let me just clear this. and return this to 10. So we can modify this to kind of look like object-oriented programming. So let me just define a variable here. I'm trying to mimic how object-oriented programming works. So maybe I can call this variable, let me call it count, then assign it the value n. So this n will be assigned to this value count. Then here I can increment count like that. So I'm trying to mimic how object-oriented works, but we'll write the real code for object-oriented. You can see it still works. So let me just write the real OP code. So for object-oriented code, you'll first have to create a class. So I'll create a class. I'll call it counter. So this class we can use just like other languages. You need a constructor. So I think I added a breakpoint. You need a constructor there, like that. So in JavaScript, you just use the constructor keyword to create a constructor, and this constructor kind of behaves like this other function. This one kind of behaves like the class. Then this function here behaves like the constructor. Okay, so this constructor will take n. Then it will return. You want here we used closure to make this n not go out of scope. But here we'll make a member variable with it using this keyword so that we can maintain it in scope. So I'll say this dot n is equals to, I can just let me just put n, but you can just put also here counter, but let me just put n so that I don't confuse myself. So this keyword with the current instance of the object that will be created, this dot something. If you don't understand this, you can check out our course for the object-oriented JavaScript. I'll put the link in the video description. You learn more about object-oriented JavaScript here. So now I think that one is here. We are done till here. Now you want to create this function. Here in OOP they are called methods. So I'll create a method. I'll call it increment. And yeah, you don't need the function keyword. You don't need this function keyword in classes. You see it's an error, so you don't need this function keyword here. Just write it like that, increment. Then what this function will do, you'll just return. There this does, it returns the value, then you increment it. So I'll return this dot n, then plus plus, like that. So you can see like this one is almost similar to what we had up here. So now let me just call it, and you can see first I have to create an object. So I'll create an object. I'll call it counter, like that. Counter. What did I call this one? I think I have to comment. Let me just comment this code up here so that it doesn't conflict with what I'm writing down here. So yeah, counter. Then I'll call it with the value 10, like what we did up here. You are doing this line of code now. I called it to this class, then pass the value 10. Now that we have this object counter, we can access this method here, increment. So I'll just say counter dot increment, like that. So once I call this with you see I created the object with the value of 10. So if I call this, I expect this one to return 10. I have to log it. Let me just log it before I forget to log it. Let me log it. Here, console.log. That. So for this first value, I'll expect it to return 10, just like the way we did before. Then this one will be 11, this one will be 12. This one should be 11, and this one should be 12, like that. So this is how you solve this with the object-oriented programming. So you can just run to confirm it also works. Oh, there's an error. Let me check it. Says there's an error with the counter. Think I missed the syntax. I forgot that. Yeah, and you see it works just as intended. So this new is used to, it's a keyword used to create an object using the constructor. So that is it for this solution, guys. Let us, you can see it always, it just similar, it is similar to the closures one, just a little bit, just a little different. If you don't understand about this code here, I know you have not talked about it in this challenge. So if you don't understand about the classes, you can watch our JavaScript video that teaches you about the object-oriented JavaScript. So that is it for this video, guys. See you in the next video tomorrow. Peace out.